Hello scholars, in this video we are going to continue solving the past question papers. Please make sure that you subscribe to this channel, click on the notification button so that you'll be notified whenever I post a new video. And also, please get your pen ready, your books, so that as I'm solving, you are also solving. Don't just sit down and watch this like a video. If you sit and watch like a video, you will not be able to grasp most of the things. But when you sit down, take your pen and your book and then follow like a normal lecture, then you get the full details of this class. And also, you should like the video. I believe you like it. At least give it a thumbs up in the dashboard below. Now, we have the first question here. The first question here says, which of the following general electronic configuration belongs to the halogen? Which of the following electronic configuration belongs to the halogens? Now, the halogens are the group 7 elements. Now, we have special group in the periodic table or special group name. The group 1 are called alkaline metals. The group 1 are called alkaline metals. The group 2, this group 1, group 2 are called the alkaline earth metals. The alkaline earth metals. The group 3 are called the metalloids. And then the group 4, the group 3, they don't have a special name. This group 2. The group 4 are called the metalloids. Group 6, the group 5 don't have a special name. The group 6 are called chalcogens or the ore formers, or you can call them ore formers. And then we have group 7, they are called the halogens. And then group 8, the group 8 elements are called noble gases. They are called the noble gases. So these are the various groups in the periodic table and their various special names. Now, like I told you before now, that the group number gives us information about, or the valency gives us information about the group number. So if an element is in group 7, it means that that element has how many valence electrons? 7 valence electrons. Okay? If an element is in group 7, it means that it has 7 valence electrons. And the halogens are the main group elements. They have 7 valence electrons. So let's begin to eliminate out. Now, from our initial understanding, we said S orbital can take a maximum of how many electrons? 2. P orbital can take a maximum of 6. D orbital can take a maximum of 10. And F orbital can take a maximum of 14. Now, if you have NS2, NP7, this is a wrong configuration because this P orbital can take only how many electrons? 6 and not 7. Now, let's look at this, a noble gas. That means the configuration of any of the noble gases. Then NS2 and NP5. Now, is this correct? Now, this noble gas is telling you that this part downward is filled up and it's another shell. Then after the noble gas, you start a new shell entirely. Is that not so? So all these ones, they are inner shells. This other one is the new shell, which is the outer shell. Now you have NS2 and NP5. I said that whenever you have something like this, in such a way that there is N here and N here, they are the same. It means that the energy level are the same and the shells are the same. If the energy levels are the same, that means they are in the same outer energy level. Hence, you should add the number of electrons here. So this will give us 2.2 plus 5, and that is what? 7. So this one has 7 valence electron, and it conforms to the normal configuration because this was NS2, NP5. The p orbital can take up to 6 electrons, but we have 5 filled up here. So this is the correct configuration. Now this is wrong. This is wrong. Okay, this is wrong. So the correct configuration is this. Now let's look at the next. The next question says, which of the following compound is the most ionic or is ionic? Which of the following compound is ionic? Now, what is ionic compounds? Ionic compounds are compounds. They are compounds. Ionic compounds are compounds that have atoms with large electronegativity difference. Okay, the atoms that form ionic compounds, they have large electronegativity difference. So if you look at these compounds very well, which of them do you think have high electronegativity difference? Now, you may not be able to predict the electron, or you may not be able to state the exact electronegativities of the atom, because you are not useless to start going to memorize all the electronegativity of all the elements in the periodic table. But due to written down rules, we should be able to predict the electronegativity of each of the atoms here. Now, if you look at the first one, this one is sodium oxide. Now, sodium is a group 1 element. Oxygen is what? Group 6. You see how far they are. Electronegativity does what? Increases across the period. So it means that sodium is very, very much less electronegative than what? Oxygen. Is less electronegative than what? Oxygen. Now, let's look at the next one. The next one you have here is N2O. Now, looking at nitrogen oxide, you discover something. Let's look at N2O3. Now, between nitrogen and oxygen, nitrogen is a what group in the periodic table? Group 5, and oxygen is in what? Group 6. The electronegativity difference between these two, of course, is not as large as the one between sodium and what? Oxygen. Because immediately after nitrogen, you see oxygen in the periodic table. Now, how about this one, phosphorus? Let's talk about the bond between phosphorus and oxygen. Now, phosphorus is in group 5. Oxygen is in what? Group 6. Just that phosphorus and oxygen are in different period. Phosphorus is in period 4, I think. That is 2, 8, 8. Let me write. It's 13 now, which is 1s2, 2s2. Phosphorus is 15 rather. 2p6, 3s2, 3p3. That's how many? Group 3. Phosphorus is in group 3 and oxygen is in group, phosphorus is in period 3 rather. Period 3 and oxygen is in period 2. But phosphorus is in group 5 and oxygen is in group 6. So you see that their electronegativity will be so close. Are you getting it? As compared to that of this. This is 5 and 6. Now, how about SF4? Sulphur is a what group in the periodic table? Group 6. And fluorine is in group 7. In as much as they are in different period, but the electronegativity will be so close. So the one that will be ionic among these compounds will be what? Will be N2O, which is Na2O, which is sodium oxide. Why? Because sodium is a group 1 element and oxygen is a what? Group 6. So the electronegativity difference is so large, and because the electronegativity difference is large, we can say that such a compound is what? Ionic. So the correct answer to this is option A. Now let's look at the next. To which group of element does sulfur belong in the periodic table? Now, sulfur is in group 6. Let's confirm it. Sulfur is in group 6. This sulfur here. Here is sulfur. This sulfur here is a group 6A element. Group 6A. Is that understood? 6A element. Look at it here. So sulfur is in group 6. So the element, to which group does sulfur belong? The correct answer is group 6. And that is option. Here is 6 here. There's no 6 here. To which group of element does sulfur belong in the periodic table? This is 4. This is 14. Okay. We can also say that it belongs to group 6 or group 16. Group 6A or group 16. Which is what you can see here. It's either I call it 6A or you call it group 16. Okay? So it belongs to group 6A or group 16. And that is option C is the correct answer. Either group 6A or group 16 when you are considering the 18th configuration. Like you are considering the periodic table as having 18 group, it will be in group 16. If you are considering it as having 18 group, each of these group are 1. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Are you getting it? This is where sulfur is here. So that is that to that question. Now, let's look at the next question. One of the following elements is a metalloid. Now, metalloid, as I said, are the semiconductors and they are group 4 elements. All metalloids are semiconductors and they are group 4 elements. An example of an element that is found there is silicon. Silicon is in group 4. Let's look at it together. Silicon, you can see it here, is a metalloid. It's a group 4E or 14 element. So it's a metalloid. So the correct answer to this question there is silicon. Group 14A or group 4 element. Let's look at the next. The earliest thinker of atomism was... Now, one of the earliest thinker of atomism was... Now, the earliest thinker of atomism was Democritus. He actually said, or he was a philosopher, where he propounded that the atom is the smallest uncuttable particle of an element. They were looking for the universal stuff of the universe. That is what the universe is comprised of. So many scientists actually discovered or they propounded so many things that made up of the universe. Some said it is fire. Some said it is water. Then some said it is number. And from there we have the Pythagoras school of thought. From there they propounded the Pythagoras theorem. The difference between this and this. When you sum this and this together, it will give you what you have here. Then we now have the atomism school of thought, which states that, which was the major exponent rather was Democritus, and he propounded that the atom is the smallest uncuttable particle of an element. But this idea was rejected by Aristotle and this other man here. Okay, so that is that. Now, the valence electron of representative elements are... Representative elements are elements that have their valence electron either in an s or p orbital. They have incompletely filled s or p orbital. Okay. Now, the valence electrons are the electrons in the outermost shell. Also, you should note that valence electrons are electrons in what? Outermost shell. While the core electrons are the electrons in what? Innermost shell. So all electrons in the inner shell are called the core electrons, while the ones in the outermost shell are called the what? Valence electron. Now the question is, the valence electrons of representative elements, are they in s orbital only? No, they are either in s or what? P. They are located in the outermost occupied major energy level. This is true. Then located closest to the nucleus. No, the innermost electrons are the ones located closest to the nucleus. Then we have located in d orbital. This is wrong. So the correct answer is option B, which is located in the outermost occupied and major energy level. The next, which of the following does not have a noble gas electronic configuration? Now, all these species here, from here to here, all of them are isoelectronic, except they are isoelectronic except one. So let us bring them out. You have S2 minus, Ba plus, aluminium 3 plus, and antimony 3 minus. Now let's look at them one after the other. S2 minus. Normally, sulfur this sulfur has 16 electrons, which is atomic number of 16. Now this 2 minus means it has gained 2 electrons, okay? So you now add 2 electrons to it, and a total 16 plus 2 electrons will give us what? 18 electrons, okay? So it has a total of 18 electrons. Now let us look at the next one. The next one is barium. Let's look at barium. Where is barium in the periodic table? This barium, it has 56 electrons. Now we'll now come back now and see the charge on barium. 56 electron. This plus here means barium has lost 1 electron. Is that understood? So 56 minus 1 will be what? 56 minus 1 will give us 55 electrons. Now we have the next one, aluminium. Aluminium is 13 electrons. This 3 plus means it has lost 3 electrons. So we have minus 3 here. And then 13 minus 3 here gives us how many? Give us 10 electrons. In chemistry, whenever an atom loses electron, it becomes positive charge. So if you lose 2 electrons, you say plus 2. If you lose 3 electrons rather, it becomes plus 3. However, if an atom gains electrons, it becomes negatively charged. So if it gains 2 electrons, it becomes 2 minus. While if it gains 3 electrons, it becomes 3 minus. If it gains 1, it becomes what? Just minus. Okay? So let's look for antimony in the periodic table and see if it will have a noble gas configuration. Antimony. Antimony is in group 5. I think so. Antimony is in group 5. Now, SB 51. Now, what we are going to do, we have 51 minus 3, and this will give us 48. Now, let's see all of them here. The one that will have a noble gas configuration. Now, 18 has a noble gas configuration, which is the configuration of what? Argon. Let's check it. 18 is argon, okay? So we come back here and say okay, 18 is argon. So we can come back here and say this is, now this is supposed to be 3 plus. Okay, 3 minus means it gains electrons. Sorry, that was my mistake. 3 minus means it gains 3 electrons. So 51 plus 3 is what? Is 54. Sorry about that. So 18 is argon. So this obeys, or this have a noble gas configuration. How about 55? Does any noble gas have an electronic configuration of 55? I doubt. There is none. So we come back and say this is not a noble gas configuration. How about 10? Neon is 10. How about 54? I think xenon is 54, which is this also a noble gas. 54 is a noble gas. Okay, so this one also have a noble gas configuration. So we can say this is xenon, noble gas. So the correct answer to this question now will be this, because we are looking for the one that does not have the noble gas configuration, and hence the correct answer is barium plus. That is the right answer to that question. Let's look at the next. Which of the following formulas for ionic compound below is incorrect? Now you have SrCl2. Is this correct? Now you have to look. Strontium is in group 2, so it has 2 plus. Chlorine is in what group? It's in group 7, so it has 1 minus. Now, if they exchange, we are talking about the valency here, or the oxidation power here. So if they exchange valency, what will this become? This become SrO. That of chlorine will come here as 1, and then chlorine will take 2 of what? Strontium, and this become SrCl2. So this first one is correct. Now, calcium is in group 1. You can check that from the periodic table. Calcium is in group 1. Strontium is in group 2. That is why it has 2 plus. Calcium is in group 1. So it has 1 plus. Okay? Now, if you look at it very well, calcium is in group 1. So it has plus 1. And then sulfur is in group 6. Sulfur needs 2 electrons to complete 8 electrons. So you have it as what? 2e minus, which is 2 minus here. Okay? when they exchange valency, what are we going to have? Calcium, sulfur oxidation will come here. So we have CS2, and that of sulfur will become what? 1 here. And this becomes CS2S. And this is correct. Now, how about aluminium? Aluminium usually has this oxidation state of 3+. Now, chlorine usually has oxidation state of what? -. If they exchange valency, this becomes Al1Cl3, which is 1 is often neglected, so you have AlCl3. This is correct. Now, automatically, you know this is wrong, right? But let us confirm to see if the question is correct or not. Now, aluminium is 3+, and the phosphorus is aluminium and phosphorus are in the same period, so and the same group. So this will also have 3+. Aluminium is 3+, phosphorus is 3+. Is it 3+? No, they are not in the same group. Aluminium is in group 3, phosphorus is in group 5. So this one is 3-. Okay? Because it needs 3 electrons to complete the atomic share. So when they exchange valency, this one becomes Al3P3. Where this one will cancel this, and this becomes ALP normally, or just Al3P3, anyhow you want to put it. So this one is wrong the way it is, and hence the one that is wrong becomes the correct answer. So this becomes the correct answer. Okay, now let's look at the next. Which of the following is considered as nonpolar covalent? Now, nonpolar covalent bond is, there are covalent bonds that have close electronegativity difference. Okay, so all covalent bonds with close electronegativity difference are called nonpolar. If the electronegativity of the two atoms are close, you call it nonpolar covalent. Now let us examine them one after the other, taking HI. Now, hydrogen is in what group in the periodic table? Group 1, and this one is what? 7. So if this is a covalent bond, we can say that this one is what? Is polar. Are you getting it? If this is covalent bond, we can say this is what? Polar. Now let us talk about HS in H2S. Hydrogen is in what? Group 1. Sulfur is what? Group 6. So this is 1 and 6. If this is form a covalent bond, because electronegativity of sulfur and that of hydrogen is somehow too close, the difference is not enough to call this ionic bonding. Okay, now if this forms a covalent bond, the difference between the electronegativity is also high, so this will be what? Polar covalent. We form polar, that means positive charge here and then what? Negative charge here. So this will form polar covalent bond. Is that okay? Now let us consider PCl. Now, phosphorus is in group 5, chlorine is in group 7. Now, the difference between these two is not as large as this one. So we can say that this one may be what? Polar or non-polar. Let's just take polar and then consider that of this particular one, NCl. Now, between phosphorus and nitrogen, which is more electronegative, we are told that nitrogen is on top, then phosphorus is under. Now, electronegativity, does it increase from top to bottom or it decreases? It decreases from top to bottom. Are we getting it? It decreases from top to bottom. So it means that nitrogen is more electronegative than what? Phosphorus. And if nitrogen is more electronegative than phosphorus, so it means that the electronegativity of nitrogen is closer to that of what? Chlorine. Because chlorine is more electronegative than what? Nitrogen. Chlorine is also more electronegative than what? Let's say phosphorus. So if chlorine is, let's say, 7, and then between nitrogen and phosphorus, let us say nitrogen is more electronegative. Let's say nitrogen is 6 and phosphorus is 5. If we put this here, nitrogen is, let's assume this 7, let's say nitrogen is 6 and phosphorus is 5. This is assumption now. Which of them do you think has electronegativity very close to that of chlorine? We can say is what? Nitrogen. So between the choice of phosphorus and chlorine, the right answer to choose now is nitrogen and what? Chlorine, because they have very close electronegativity as compared to that of phosphorus and chlorine. So we can say that this one is non-polar. Okay, this is non-polar. So if you are given any compound like this and you enhance to identify the one that is non-polar covalent, the ones that have close electronegativity difference or close electronegativities are said to be non-polar. So in this case now, NCl will be non-polar. Okay, NCl are non-polar. Let's look at the next. Which of the following compound is most likely to be ionic? Which of the following compound is most likely to be ionic? You have gallium and arsenic. Now, gallium and arsenic are very close to each other in the periodic table. See gallium here, see arsenic. I don't think they can form ionic compound, okay? So this is wrong. They can't form ionic compound. Scandium and chlorine. Let us look at scandium. I think scandium is in group 1, okay? Scandium should be in group... Okay, scandium is not in group 1. Scandium is in group 3. Group 3b. Or group 3. Then chlorine is in what group in the periodic table? Chlorine is in group 17. So we have difference of 3 and 17. 3 and 17 for scandium chloride. So we have 3 and 17, which is 3 and 7. Now NO2, nitrogen is in group 5, oxygen is in what? Group 6. Then we have CCl4. Carbon is in group... Carbon is in what group in the periodic table? Carbon is in group 4 and chlorine is in group 7. Now, which of them do you think have a higher electronegativity difference as compared to each of them you have here? So now making a comparison between the one that is most likely to be ionic. Now you see that this one is 3 and 7. The electronegativity difference, if we want to assume, is 4. While this one is 4 and 7, this one is what? 3. 5 and 6, difference is 1. This is gallium and arsenic. They are almost the same, which is 4. Gallium is group 4. And gallium is in group 3 and arsenic is in group 5. This minus this is what? 2. So which of them have a larger electronegativity difference? Because that is what will make you, or that is what will give you an idea of the one that will be most ionic, is what? Scandium chloride, and hence the correct answer is option B. Now let us go to the next. The electron dash structure for hydrogen cyanide is... Now hydrogen cyanide is written as HCN. Which of them will be the central atom? Carbon. Now, carbon being the central atom, nitrogen is what? Carbon has how many electrons in the valence shell? Carbon has 4 electrons in the valence shell. Nitrogen has how many electrons in its valence shell? Nitrogen has 5 electrons. Now, nitrogen, we need how many electrons to complete it? Nitrogen, we need what? Plus 3 electrons to complete it. Now, note, the 3 electrons that nitrogen needs, carbon has to provide them. So first of all, we say carbon will provide 3 electrons to nitrogen. Now, as carbon is providing the 3 electrons to nitrogen, nitrogen is also bringing its own 3 electrons to complete or to collect the 3 electrons that are given to what? Nitrogen by carbon. So even nitrogen himself will also bring in 3 electrons so that the pair will be what? Complete. And then if nitrogen gives her 3 electrons, it already has 5 before normally. If it gives 3 electrons to carbon, it means that it will be left with how many electrons? 2. So the 2 electrons will be what? Lone pairs on top. Now the next thing is hydrogen. Hydrogen is having 1 valence electron. Now hydrogen does not obtain octets, rather it obtains octets, which is 2 electrons. So it will need 1 more electrons. 1 plus 1 is what? 2 electrons. So this 1 electron of carbon will now bond with 1 electron of hydrogen. So this is the structure, and this becomes C, triple bond what? N, then lone pair of electron here, and then hydrogen. So what would you call this now? How would you explain this? You can say that this is S, C, triple bond N with 2 lone pairs of electron. Now, you have 2 double bond. There's nothing like double bond here, so this is wrong. 1 carbon hydrogen bond, 1 carbon double bond nitrogen. This is wrong. There's nothing like double bond carbon nitrogen. 1 carbon hydrogen bond, 1 carbon nitrogen bond. There's nothing like 1 carbon nitrogen bond. It's 1 carbon triple bond nitrogen bond that we have there. So we have one triple bond between carbon and nitrogen, that is correct. One carbon and hydrogen bond, there's a carbon and hydrogen bond, that is correct. And one lone pair of electron on the nitrogen atom. This is what? Very, very correct. So the correct answer to this question is option D. Option D is the correct answer to this question. So that will be where we are going to stop for this episode. Thank you for your time.